external function that we'll call, and it's going to bridge a specified token for us. So we call this function bridge token to other chain with message. It's going to take any ERC20 token address. ERC20 is a standard in Ethereum that once you write a contract and it follows ERC20 standard, we call that token ERC20 token. So we are going to need to get the balance, how much of this token our contract has, so we can bridge. So in this function, we are going to get the balance of this token we have in our contract. Address this refers to the current contract, this contract we are writing. Balance of is a function inside this ERC20 token. We'll call it's going to return the amount of token we have in this contract. And we are going to save it as an integer UN256 inside this variable called input amount. So once we know the balance we have in this contract, then we are going to call an internal function. And I'm going to call that internal function underscore bridge to other chain. Now, this function is just the main difference between this function and this function, besides the name, is the visibility. This is external. External functions can be called by contracts that are outside our contract. They can also be called by wallets outside our contract. But internal functions cannot be called by anything outside our contract. It can only be called within our contract. So to make it easier, I'm going to define it down here. So this internal function will be the one that will call the across protocol and do the actual bridging. So one of the parameters we have to pass inside is the amount of this token we have. So let me just put it here. Okay, so unit 256 and the amount of it that we have. All right, so let's now go. Now, if you go up here, you'd see we have error. We have error because we have not been able to import this interface, ERC20 interface, which we are calling down here. Now, to import it, we have to install this Open Zeppelin contract. As I said, this ERC20 is a standard, and so it's a standard library like Open Zeppelin has helped us to write this ERC20 standard. We don't need to write it out like we did over here that we went to copy it. Now, in this case, all we just need is to install this Open Zeppelin contracts library, and this will be available for us to import. So in order to do that, I'm going to press Command J, and it brings up my terminal. And this is the command we are going to run: forge install Open Zeppelin contracts. If this command does not work for you, you may need to add --no commit, and you can run it. Now, you can be getting error. If you get error, try and post your error on Google, and you'll probably see others who have actually encountered such error and how they solved it. That's how we debug in software development. Basically, so another thing you can do is just to paste your error in ChatGPT, and yeah, sometimes it's annoying. Installing dependencies can be much more difficult than the code itself. All right, so run it. Once you run it, I just did it. I just installed it. So once you run it, you are going to, in your library here, you're going to see the Open Zeppelin contract here. Now, if you follow this directory, we will see this IRC20 the interface we imported. So let's go to contracts, let's go to token, let's go to ERC20, IRC20. So this is the function balance of accounts. So it takes the address of any contract or any wallet you want to get the balance of, and it returns you on unsigned integer 256. So this is you in 256. If you want to understand this more, you need to watch my multi-dex arbitrage bot video. I explained that more there. All right. So back to what we are doing here. Now, there's one more thing we need to do is to come to this foundry.toml file and so we will need to define what this at OpenZeppelin means. So that will make it easier for our file to locate this interface and stop showing this error. In the foundry.toml file, we'll come here and we are going to define these remappings. These remappings tells our contract that whenever it sees at OpenZeppelin/contract, it should replace it with lib/OpenZeppelin contracts here. So over here, so it's just going to remap this and direct our contract to where this is correct, where it is. All right, so to see that what we've done so far, hopefully you should remove this error sign very soon. But to be sure of what we have done so far, let's just compile. And the command to compile our contract in Foundry is forge build. So you run forge build and let's see, everything seems to run. Okay, so we are getting some questions here. So basically, it just wants me to add this, that I am importing this IERC20 from this contract. You can see the error has gone. All right, that's good. So let's move on. Now let's come down here in this place. We need to come here, our interface. What we are interested in calling is this deposit v3 function. So I'm just going to copy it like this over here. So we need to call it, don't forget we've defined call this contract and it should be available in it. Yes, these are all the parameters we must pass in it before we can call this function. We can call this contract because the work of this contract, this deposit v3 function, is to take our token from this contract and take it to the other chain for us. We need to first of all approve it, give it approval that okay, you can take some amount of token from us, and this is how we do the approval. There's this functionality on ERC20 called approve. This approve function, you have to specify the contract you are giving approval to and the amount of token you are telling it you are giving it power to take from your contracts, and you have to specify that token itself. So this is how you do it. Now, after we have done that, there are many parameters we need to pass in, input token and this and this. Okay, so let me now uncomment this. Okay, there will be much error, but this contract is doing something I don't like. The width of my code is too small, so I'm going to import prettier here and make it look nicer. So if you want your code to also look nice this way, you just need to create this two file, this .prettier rc, and you need to add this print with 160 single quotes through trailing comma or, and the prettier.ignore file, this, and that would ensure that our code look nicer. But it's not really important, it's just for your code to look nicer. So let's move on. So let's see what this means. If you go through the documentation, you'd see the definition of each of the parameters here. The depositor is whoever is calling this function, and recipient is the contract on the destination chain, in this case Arbitrum, and that would be the contract or the wallet we are sending it to. Input token is the token we are sending. Output token is the equivalent of that token on the destination chain. It's just address. So address of worth on the base chain where we are sending it from. Output token will be the address of worth on Arbitrum. The amount we are sending in, the output amount, you will see how we are going to get that from making API call to across protocol. The destination chain, this will be Arbitrum chain ID. Exclusive relayer, that would not be important. We will just put address 0. Quote timestamp, we are going to get the current timestamp for that. Field deadline, you see how we'll get that in just 1 minute. We are going to get that. Exclusivity deadline, that's going to be 0. Message, this is the message we are going to put. We are going to encode along with the token we are going to send. So here, I'm going to pass the parameters here. These are the parameters we are going to pass in over here. Let me just close this up. Yes. And that will help us to supply those parameters inside here. I'm going to just comment out this, and this is the implementation. That will be easier for you to see the difference now. So you can see for the depositor, it's a parameter we are passing in. The recipient, also a parameter. This is what I need you to pay attention to. The across spoke has this function called get current time. That is how we are going to get the quote timestamp. It's just the time you get the time we make the API call. You'd see when we make the API call, it comes with the quote timestamp. So it's a parameter we're going to pass in. Now, it's not in unit 256. Unit 256 is byte 32. So we are casting it down from unit 256 to unit 32. Now, in order to ensure that we don't get error or trim out parts of the values here, we have to use this library called savecast.unit to unit 32. It's one of the Open Zeppelin libraries. So we need to import that. Now, for the field deadline, you can see how we are getting that out. For the field deadline, again, from across pool, we have to call field deadline buffer. Then we add it to the current time, which is the block timestamp. Exclusivity deadline, as I said, is 0. And this is our message we are also going to pass in as parameter. So finally, we emit an event. It's a standard practice that whenever you make state changes, you emit an event. Events are things your indexer listens to and makes it available, makes the recent state changes you have made available to your front end so that your front end render the appropriate page for the user. Hopefully in my subsequent videos, I'll do a full stack video and you see how we build indexers and how important this is. So we've emit an event, but we have not defined it. That's why we are getting this error. So we are going to come up here and I'm going to define the event here. All right. So we've defined the events. You can see the error has disappeared. And you notice that my code width is now wider. So which is the essence of this prettier file. Now let's define this and resolve the error there. I am going to get these safeguards from the Open Zeppelin library. This is it. So let me just bring it out like this. All right. So we have it. Does it disappear? All right. Yes. I'm also going to bring it in here. We might actually need it as library. So this is how you define library using safecast for uint 256. Now we finished this internal function. Let me get rid of this. All right, so we are going to call this internal function inside this external function. So I'm going to get rid of this. So what this means is whenever we call this function, it's an external function. It's just, it gets the balance of our contract and pass it in as one of the parameters for this internal function, which would do the bridging for us. So there are many parameters we've not defined here. So let's define them. I'm going to come here now and define the input parameters. All right. So we are going to supply, whenever we call this function, we are going to supply the chain ID, the recipients, the input token, output amounts, and the message. Yes. Now, but there is a challenge. This function, it's quite important because it's moving funds from this contract to another place. We should restrict the calling of this function. It's an external function. Anybody can call it. So we need to ensure that it is only us or those that we allow that can call this. I'm going to come up here now, just above the constructor, and I'm going to define a modifier called only whitelisted. All right, I'm going to create a mapping up here. Here, just be patient with me. I'm creating this is whitelisted mapping. What this is whitelisted mapping does is that it takes any address and returns true or false to us, this boolean. Now is whitelisted modifier. Just be patient. You'll see what I'm going to do with this only whitelisted modifier here. I'm going to put it here, and it will be easier for me to explain this way. Is only whitelisted modifier. Whenever anybody calls this function, this only whitelisted modifier will check the address calling this function, and it will come and check who is calling this function. Is it true that this person is allowed to call this function? If it is true, the person will be allowed to call this function. That's why you have this underscore. It will run the code. Now, if it is false, it will revert with this error, unauthorized error. So the person is denied from calling this function. I'm using modifier. Modifiers are just conditions that you have to test for different functions. So in order to ensure that you don't repeat code, just put the condition in a modifier. Then every of your function, you just restrict them. Just place only whitelisted on it, put the modifier on it, and your condition will always be tested. Now we are getting error here because we've not defined this error. So I'm going to come up here, just up here, somewhere here. I'm going to define this error. All right, so this is fine. So what that means is that even we ourselves, the owner of the contract, has to be whitelisted before we can call this function. So I'm going to come to the constructor and say at the point of deployment in this constructor, we, the deployer, which is msg.sender, whoever deploys this contract, sets is whitelisted for him to true. So he will be allowed to call this function. All right. Two functions here. The first one is whitelist address. So this function allows us to add more address and whitelist it so that address. So if you want to allow your friend to use this contract, or you have multiple wallets, so you just need to whitelist the second address too, and you'll also be able to use this contract to bridge. Now you can also use this one to remove that address, so it will just turn its whitelisted mapping to false for that address. That's all. This one turns it to true, this one turns it to false. But we need to ensure that it is only us, the owner of this contract, that can call these two functions. That's why you see this only owner modifier here. And we have not defined this modifier. That's why we are getting error. So let's do that one too. Now I've shown you how to define modifier. Yeah. Now what I've not shown you is how to import it. There's this Open Zeppelin contract called Ownable that helps us to get that only owner modifier too. So instead of defining it as we did for whitelisted, so I'm going to import it from Open Zeppelin contract, and this we are going to inherit this in our contract is Ownable, and that should make this to be available. Now you notice we have an error. We have an error because let's go into this contract and let's see. This abstract contract that we are importing has a constructor and is the initial owner. So this constructor, we need to pass this. The address of the owner, we need to pass it into the constructor. So let's just come back here and let me show you how we are going to do that. We come to the constructor here and we have to add ownable. msg.sender is whoever deploys this contract, his address is passed into this and makes us the owner. So you'd see the error has disappeared now. All right. And define another helper function. So this is set contract address on other chain. So what this helps us to do is, we are going to be deploying this contract on multiple blockchains. So this will help us to keep track of the contract address of those contracts we deploy on other chains. So if we deploy it on Arbitrum, the chain ID of Arbitrum, and the contract address on Arbitrum, we are going to keep it here. If we deploy it on Ethereum mainnet, the same thing, we can store it here, so we can keep track of that. So I'm going to come down here and define the mapping contract address on. So you can see the error has disappeared now. So it just takes the chain ID and sets it equal to the contract address. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. The next thing, let's check it on our menu, is a function to swap tokens on Uniswap v3. Again, all these protocols you're seeing are contracts deployed on the blockchain. And how do we interact with contracts deployed on the blockchain? You guessed it right. We need the ABI or interface of the contract and the contract address. So the same way, I'm going to leave the link to the documentation of Uniswap v3 in the description of this video, so you can get that. And you also need to watch my multi-dex arbitrage bot. I showed how to get the interface for Uniswap v3 there. So what I'm going to do is to come to this interface folder again. I'm going to create a file. I'm going to name it idexis. So for Aerodrome and Uniswap v3, this is where we're going to put their interfaces, right? Now there are some things missing here. Over here, I need to define the license and the solidity version. All right. So this is Uniswap v3. We need these structs, and this is the function we are going to call to swap. So this struct contains all the parameters we must pass in for swap to take place on Uniswap v3. While I'm here, let me just get the interface of Aerodrome v2 so that we'll just import everything together. So in Uniswap v2, Eldrum v2, we are calling this function swap exact tokens for tokens. This is what we are going to be calling. This will help us to get our amount out, our minimum amount out. I'm going to explain that when we get to that point. And this is a struct. These are the parameters we need to supply. So let's import both of them into our contract. Then we can start implementing. I'm going to come down here and import the two interfaces, Eldrum and Uniswap v3. We'll implement Uniswap v3 first. Now I'm going to come down here and I'm going to implement an internal function that will help us to swap on Uniswap v3. Don't forget, we need ABI and contract address. We already have our ABI up here, so we need to get the contract address. I'm going to come up here, and just as we did for the across spoke, we are going to define the contract address of the Uniswap v3 router address. Again, I'm going to leave the link to the documentation of Uniswap v3. I'm going to leave it in the description of this video so that you can easily get this router address. But basically, this, since it's immutable, we have to define it in the constructor and give it a value. So it will be Uniswap v3 router. So this must be an address that comes in, that we are going to pass into our constructor, our deployment. I'm going to come down here and define a state variable for holding the contract Uniswap v3 router contract itself. It's meant to be immutable. I forgot to make this also immutable across pool contracts. You can see this instance of the contract, we just set the value once in the constructor and we are not going to change it again. In fact, it's not necessary. So yeah, so let's do that. So I'm going to come here to the constructor now. I'm going to come here and define the contract itself. You can see I'm wrapping the Uniswap v3 interface around the contract address coming in so that we get the contract in the Uniswap v3. So over here, let's continue with our internal function. Let's quickly check the Uniswap v3 interface we imported. Over here, the interface here, indexes. Now, this is what we are calling. No, okay, down here. This is what we are calling, and we are calling it with all these parameters in the struct. At the end, it's going to tell us the amount of the token out you're going to get. So if we pass in wrapped Ethereum, it's going to swap it, for example, to USDC, if that's what we are saying, and it's going to return the amount of USDC we are going to get to us. So back here, we are going to return the amount out to us. So this is the function itself. We have to define these struct params we are passing in.